Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about diagonalization of your matrix. To complete the lecture, we are going to in detail discuss about definition of eigenvalue and eigenvector, then how to find the value of eigen and eigenvectors, definition of modal matrix and spectral matrix, how to find modal and spectral matrix, arbitrary constant, and how to diagonalize the given matrix, that is diagonalization. These all the topics, everything will be covered while solving the problem. First, definition of eigenvalue and eigenvector. That is, let capital A equal to Aij. That is, this capital A, it's nothing but our given matrix. Here, this I stands for row, J stands for column, and n by n it is given. That is, the number of rows and number of columns are equal. That means the given matrix, it should be a square matrix. Then a non-zero vector capital X. This capital X should not be a zero vector. It should be compulsory non-zero vector. You can see here one column matrix is given, that is column matrix, because it has only one column, and it is a zero matrix also, because all the elements of this column matrix 0. It is a zero matrix. But according to this definition, the capital X should be a non-zero vector. You can see here. That is here 1, 0, 0. This is a non-zero vector. That is, this capital X should be this type of matrix. Then it is said to be a characteristic vector of capital A. That is the given matrix. If there exists a scalar lambda such that Ax equal to lambda x. If Ax equal to lambda x, where x is not equal to 0, that is, x is a non-zero matrix, it is not a zero matrix, then capital X is the eigenvector, or we can call it as characteristic vector of capital A, corresponding to the eigenvalue, that is this lambda of the given matrix A. So this is the definition of eigenvalue and eigenvector. This point we have to keep it in our mind. A is the given matrix, lambda is the eigenvalue, and capital X is the eigenvector, and capital X is a non-zero vector. So next we are going to solve a problem, that is finding eigenvalues and corresponding eigenvectors for the following matrix and diagonalize. Capital A equal to, this is the given matrix. It is a 3 by 3 matrix. It is 3 by 3 matrix because it has 3 rows and 3 columns. This is the condition of eigenvalue and eigenvector. Ax equal to lambda x. If lambda is the eigenvalue of the matrix A, that is our given problem, then capital X is the corresponding eigenvector, then by the definition, A minus lambda I of X equal to 0. So now, this part, how mathematically we can express, that is the non-zero solution of homogeneous system, that is the non-zero solution of X of the homogeneous system is the eigenvector for the eigenvalue lambda for the given matrix A. That is a mathematical way we have to read. Now that is written. So now A, just the given matrix we have written. The lambda, it is written as it is. And I, we have taken the unit matrix, that is the order 3 by 3. Now, here we have taken 3 by 3. The doubt, it will be ringing in our mind. It will strike in our mind that why this is the given matrix, it's fine. We copied from the question. The lambda, it is there as it is we have written. Why here this matrix we have to take specifically the order 3 by 3? Why not 2 by 2? The reason is, if this is 3 by 3, anything addition or subtraction, both the order of the matrices should be same. Matrix singular, matrices plural. So this, if you want to do subtraction or addition, see here we are doing the subtraction. So both the matrices order should be same. Thus based on that, here we have taken 3 by 3 matrix. Here this X place, we have taken the column matrix X1, X2, X3. Because it's a 3 by 3 matrix, that is the reason 3 variables are there. If it is a 4 by 4, one more it will be extended. X4 we will write. If it is a 2 by 2 matrix, we will stop up to X2 equal to 0 matrix. Now, so just this is copied as it is and the minus sign as it is. The lambda we are taking inside. Lambda, and it is copied X1, X2, X3. So just we have taken. Now 8 minus, we are doing the subtraction. So 8 minus lambda. The changes will be there only in the principal diagonal. Because minus 6 minus 0, we know it the same value will be coming. Because 0 is playing the role of additive identity. So everything will be just we can copy it from the question. There won't be any changes because the value is subtracted. What is that? To 0. So the changes will be there in the principal diagonal. So 8 minus lambda. This is 7 minus lambda. 3 minus lambda. It is written and as it is. This also we have written as it is. Now, the characteristic equation of capital A is determinant A minus lambda I equal to 0. So now you can, this notations, we have to remember that is A minus lambda I means characteristic matrix. Determinant A minus lambda I means characteristic polynomial in lambda. That is, this characteristic matrix, if you are finding the determinant, we are getting a polynomial in terms of lambda. This determinant equal to 0, then we will call it as characteristic equation. So while doing the mathematics, this we have to remember it which the symbols represents what. So this, the first one, A minus lambda I represents characteristic matrix, whereas determinant A minus lambda I represents characteristic polynomial. If it is equal to 0, it is becoming characteristic equation. Now, yes, we are finding the determinant. The determinant to find, so we have 3 rows and 3 columns. Any 6 ways are there. Among the 6, any one way we can select and we can expand. Now we selected R1 way. So that's what this, that is a red color rectangle. That is the complete, the 3 elements lie on R1. That is row 1. So the row 1, according to that, we are going to expand it. So how to do? So now this is the, so here completely if I put the tick marks, so some confusions will be there. So that's the reason I made it here separately. Now we can see it. So this is A minus lambda. That is we have taken. So you can see here. Yes. 8 minus lambda is written. Then this we have to do the cross multiplication. So this into this. So the term is ready. Minus of this cross. A minus is okay. Minus 4 into minus 4. That is a plus 16. Already minus is a minus into plus. So minus 16. So we got it. Now the row R1, first element we completed. Now we are moving to the second element. That is minus 6. Now coming to this position is signed positive. This position, the sign is minus. This position, the sign is plus. That is related, these signs are related to determinant to find signs, formula signs. But if you are taking this 4, minus 4, that is problem. The 4 minus 4 related to problem. That is the reason while solving mathematics, minus plus, these signs related to formula are related to our given problem we have to sit. Now this position minus 6 is the position is negative. Now so minus 6, that is minus 6 value is there, but the position is minus. That is the reason it is becoming plus 6. Next, this minus 6 we are taking, so complete column, that complete row we have to neglect it. The balance one we have to do the cross multiplication. That is, here we can see it, minus 6 into 3 minus lambda, 2 into minus 4 minus 8, but we know it minus of this cross. So plus 8. So now the next one, this position. So we know it signed positive, negative, positive. So the plus 2. So this, if you are taking this complete row and complete this column is not there. So the balance, this part we will do the cross multiplication. That is minus 6 into minus 4, we are getting 24. Minus of these 2, we have to do the multiplication. That is 2 into 7 minus lambda equal to 0. Now 8 minus lambda is written, then 7 into 3, 21. 7 into this minus lambda, minus 7 lambda. This one we are multiplying minus 3 lambda, and this both multiplying plus lambda square minus 16 is copied. Plus 6 minus 18 plus 6 lambda, and this is plus 8 as it is. Same we copied 2, 24. This is minus 2, minus 40. This is plus 2 lambda equal to 0. It's A minus lambda is written. Now if you are taking the lambda square, and this part minus 7 lambda minus 3 lambda, it is becoming minus 10 lambda. 21 minus 16, it is becoming plus 5 plus 6 as it is written, minus 8 plus 8, this is minus 10, 6 lambda as it is, plus 2, here we copied, 24 minus 14, 10 and plus 2 lambda. So completely this is the determinant which is equal to 0. Now, so we can see it here. Yes, just we are removing the brackets. First 8 I have taken, completely multiplied. So 8 into, yes, lambda square, 8 into minus 80 lambda, 8 into 5 plus 40. So minus lambda taking, completely multiplying, we are getting minus lambda cube plus 10 lambda square minus 5 lambda. Then I am taking this plus 6 inside the bracket. It is becoming 36 lambda minus 60. Yes, 6 into minus 10. Then plus 2 we are taking 20 plus lambda. So now, what are the terms? This is, what is that? Just I'll make it the star that we are writing. So minus lambda cube. And producing here 10 lambda square is there. We will pick up the lambda squares and all. Yes, 18 it has become. Here minus 80 lambda is there. Here 36 lambda plus here 4 lambda is there. So lambda's part I am putting. Just I'll make it this all lambda parts are there. So solving we are getting minus 45 lambda. Just it's a small simplification. Just I have taken, it's not required, same like that also we can solve. So what is that? Opposite signs it is taken. Otherwise we can tell the minus sign it has taken to the next side. So opposite signs are written. Now it is a cubic polynomial. We will get compulsory a cubic polynomial because it is a 3 by 3 matrix is our given problem, and here completely the lambda is common, it has taken out. So the balance, it is written inside the bracket. So here the lambda is, it has come one lambda out, the remaining lambda square, here the remaining part minus 18 lambda, here the remaining part is 45. So now the lambda is there, here lambda square. Now minus 18 lambda is there, so minus 15 lambda, this is minus 3 lambda. That is the factorization we did. Lambda square minus 15 lambda minus, that is minus 18 is splitted. Minus 15 minus 3. That is according to the factorization rule, that is minus 15 minus 3. Then we will be getting minus 18. Both if you are multiplying, we are getting 45. So in that angle, it is splitted in such a way. This is the basic rule of factorization. So it is written. So now, same lambda. This here in this common is lambda. It has taken. So the balance is written lambda minus 15. In this both common is minus 3. The balance is written lambda minus 15. So the both the brackets lambda minus 15 is common. So lambda minus 3, that is this part, lambda minus 3, lambda minus 15. Now, so we have to get 3 values because ours is a cubic polynomial. So the first value is lambda equal to 0. One value we got it. The next one is this lambda minus 3 equal to 0. That is lambda equal to 3. Next, lambda minus 15 equal to 0. That is lambda equal to 15. So the eigenvalues are lambda equal to 0, 350. Now we found the eigenvalues, that is 3, 0, 3 and 15. For these eigenvalues, corresponding eigenvectors we have to find. First, when lambda equal to 0, what is the eigenvector we can see? So this is the thing, a minus lambda I into x equal to 0. That is the non-zero solution of homogeneous system is the eigenvector corresponding eigenvalue of the matrix A. Now, so this is just copied. So x1, x2, x3. Now, lambda place we are substituting 0. Here, here. So substituted. So 8 minus 0. The same matrix only will be coming. After this lambda value, it is substituted in its place. Then we are getting the elements which lie on principal diagonal 8, 7, 3. So we can notice this green color rectangled one represents that. Yes. Now the multiplication we have to do it. The simple way the multiplication, we have to take the first matrix row we have to take. That is 8 minus 6, 2 is there. 8 into x1. Yes, we got it. Minus 6 into x2 minus 6x2. 2 into x3 plus 2x3. So we have taken the first matrix, first row, finished the column. Similarly, second row we will take, similar way we will multiply and we will finish the second equation. That is minus 6 into x. Fine. 7 into x2. Fine. 7x2. Minus 4 into x3. Minus 4x3. So similar way, the third row also to be done. We got it. 2x1 minus 4x2 plus 3x3 equal to 0. We got 3 equations. We got it. So this is the equations we got it. Now we have to solve these equations. For that, among the 3 equations, it's not strictly we have to take equations 1 and 2. Any among the 3, any 2 equations we can take. Here we are taking equations 1 and 2. So 1 and 2, the method. This is the method. That is, we are starting from minus 6 plus 2 plus 8. You can see where we started, we are ending. Here also you can see the middle one, plus 7, minus 4, minus 6. See the order. Next, where we are starting, we are ending. So we can check whether we are moving in a correct path or not. This is the simplest method to solve the equations to find the values of this eigenvector x1, x2, x3. That is a capital X equal to x1, x2, x3. Now, this x1, x2, x3. You can see this one. So, it is the rectangled one. This is the combination of x1, x2, x3. We will do the cross multiplication. That is x1 divided by this cross, the value. Minus 6 into minus 4, 24. Minus of this cross. So, sorry, it is written 7 2s are 14, it should be. So, 7 2s are 14, it should be. So, 24 minus 14. Next, x2, this is minus 12. This is plus 32. this one 56. Here minus of this one is plus 36. So minus of this cross, that is what reason minus of plus 36 is minus 36 equal to k. So you can see it here also, it should be from 14 it is. So x1 divided by 24 minus 14 already we got it. So 24 minus 10, here 20, this is 20. Lowest form we can take it. That is x1 divided by 1, x2, that is common 10, 20, 20, the common is 10. So the throughout these values are divided by 10, we got it 1, 2, 2 equal to k. Yes. What is this k? K is nothing but arbitrary constant. That is, we can assign various values to this k, but still it remains unaffected by the changes in the value of the variable. That is arbitrary constant. So we can take any values. Now this first we will solve it. x1, y1 equal to k. So 1 into k, k. 2 into k, 2k. 2 into k, 2k. So capital X equal to x1, x2, x3, k, 2k, 2k. So the k places we are putting the value 1. So 1, 2, 2. So k equal to 1. So this is the eigenvector. We got it when lambda equal to 0 and this arbitrary constant value, it is taken here as 1. Why not anything we can take, any various values we can assign this, but it's a non-zero arbitrary constant. That is also we have to, because compulsory here you can't take as 0. If you are taking 0, this everything will come 0, 0, 0. Then it is becoming 0 matrix, that is 0 vector we are getting. But according to our definition, eigenvector is a non-zero vector. So any value means it is not, 0 is not included. So non-zero arbitrary constant we have to take. So that is the reason when lambda equal to 0, we got this eigenvector. Next. So now we have to find when the eigenvalue lambda equal to 3, what is the eigenvector? A minus lambda I of x equal to 0. So it is written and lambda equal to 3, that is here, and 7 minus 4, and here also 0. You can see. So that green color, the rectangled ones, the values are, after substituting the value of lambda in its place, we got 5, 4, 0. These elements lie on the principal diagonal. So solving the equations 1 and 2. So before that, this multiplication we know it, how we can do it. We will take the first row, multiply it. That is the first equation, got it. Second row, it is multiplied with this column matrix, second equation. Third, it is multiplied, third equation. So first, any equations we can take. Here we are taking the equations 1 and 2. So equation 1 and 2 we have taken. So we no need to make ourselves more complicated. Simple way we have to take and we have to finish the sum. We should not give room for committing mistakes. So now minus 6, it is written, the middle one. Next, plus 2, then starting. Then where we started, we are ending. You can see, yes, we are moving in a correct path. Plus 4, minus 4, next minus 6, yes, plus 4. I started here, this again here I ended. X1, X2, X3. So you can see these animations, which will make to understand very strongly that these cross multiplications, the values x1, x2, x3. Now we can see here x1, this is the cross multiplication, minus 6 minus 4, 24, minus of this minus 8, this minus 12, minus of this cross is minus of minus 20 plus 20, next 20, minus of this cross minus 36 equal to k. K, it's nothing but arbitrary constant. So now x1 equal to, so we the same thing, it is the before slides, what is there, it is written again. Now 24 minus 18, the subtraction part, it is done here, equal to k. The common 16, 8 minus 16, the lowest form we will take, which will consume our time. So common is 8. The throughout this 3, the numbers are divided by 8. We got it 2, 1 and minus 2 equal to k. That is x1 by 2k. We can take it 2k. Then x2 by k we got it. x3 by minus 2k we got it. So capital X equal to x1, x2, x3. So now 2k, k minus 2k. That is the values are written here. The k, the arbitrary constant, that is the value is taken here 1. So 2 into 1, 2, 1, minus 2 into 1, minus 2. So when lambda equal to 3, we got this eigenvector, that is 2, 1, minus 2. Now we completed the eigenvalue 0, 3 and 15. We completed 0 and 3. The leftover is when lambda equal to 15. So a minus lambda a, capital X equal to 0. It is nothing but the non-zero solution xi of the homogeneous system. The homogeneous system, that means this equal to 0. Who is the eigenvector? That is the x is the eigenvector for the eigenvalue lambda of the given matrix A. So this as it is written. So now when lambda equal to 15, that we are going to substitute. So here we substituted 8 minus 15 minus 7. 7 minus 15, we got it minus 8. 3 minus 15. The remaining under as it is written, because we are substituting in the place of lambda the value 15. The remaining are as it is written. So you can see after substituting, these are the values are, once again it is through animation also it is expressed, that is minus 7, minus 8 and minus 12. So this is the thing, we know it. How to do the multiplication, same as it is. First row, complete the column. We got it the first equation, second row, column. So we got the second equation, third row, multiplying, we got the third equation. Solving first and 2. So first equation is written, second equation is written. So here we can see minus 6 we started, plus 2 started. Next x1, we stopped x2. So clear. Next we started minus 8, minus 4, minus 6, minus 8. So where we started, we ended. So naming x1, x2, x3. So the animations also making very strongly that this cross multiplications naming x1, x2, x3. So x1, this cross, that is minus 6, minus 4, minus of this cross that is plus 16, and this cross minus 12, minus of this cross minus 28, this cross 56, minus of this cross 36, equal to k. So x1 by 24 plus 16, next x2 by minus 12 minus 28, x3 by 56 minus 36 equal to k. So now 24 plus 16, just the simplification, minus 40 and 20 equal to k. So 40 minus 40, 20. Throughout, the common is 20. It is divided. We got it x1 by 2, x2 by minus 2 and x3 by 1 equal to k. So x1 equal to 2k, x2 equal to minus 2k, x3 equal to k. So 2k minus 2k, k. So k equal to 1. That is, we are substituting in the place of k the value 1. Any value we can take to consume our time less. That is the reason we have taken 2 minus 2 and 1. We substituted in the place of k 1. So when lambda equal to 15, so we got this eigenvector. So completely lambda, that is the eigenvalue 0, 3, 15 we got it. Corresponding eigenvectors we found it. Yes. Eigenvalue is over. Eigenvector is over. Our given question is diagonalize is our added one. So to diagonalize, compulsory, the matrix P is formed by the eigenvectors. That is the reason we found the eigenvectors. To find the eigenvectors, we need eigenvalues. That's what first we found, eigenvalue, then corresponding that eigenvalues, we got it eigenvectors. So the matrix which is formed with the help of eigenvectors is called modal matrix, and which will diagonalize our square matrix. That is our given problem. And the diagonalize, how the result will be in a diagonal matrix. That is after diagonalization. That is, that matrix is capital D. It is called spectral matrix. This is the definition of modal matrix and spectral matrix. Now, according to the definition of modal matrix, we know it. So the matrix, the P, capital P is formed by eigenvectors which diagonalize our square matrix. This capital P, how we got it? It is formed with the help of eigenvectors. That is this one, the first one, when lambda equal to 0 eigenvector, lambda equal to 3, this is the eigenvector, lambda equal to 15, this is the eigenvector. The formula to diagonalize is P inverse AP. So for this, we know A, that is our given matrix. Capital P is nothing but our modal matrix. It is formed by eigenvectors. So we don't know P inverse. So first we have to find P inverse. P inverse to find, these are the steps to be followed. First we will find determinant P. So the determinant of P, so we can see it here. First, we are taking 1. If you are taking 1, the positions we have to remember while doing the determinant. Anyway, it is a R1, R2, R3, or C1, C2, C3. The 6 ways, any way we can expand it. Here we expanded R one way. The first position signs we should remember. This one, this position, positive. This position, negative, this is positive. That is also we have to keep it in our mind. Now first we are taking. If you are taking 1, the corresponding row, corresponding column, we will neglect it. The balance 1, we will do the cross multiplication. So this, yes, we got it. This cross minus of the value of cross. So minus. The value of this cross is minus 2 into minus 2, 4. Fine. Next is 2. But here it is written minus 2. The reason is here the position sign is minus. Written. The value copied. Now if we are taking this one, so you can see it actually, this cross the animation it is done. So now I can make it here. This to concentrate here the 2. This 2, this particular column we have to miss it. Particular row we have to miss it. The balance 1 we have to do the, what is that, cross multiplication. That is 2 into 1, 2 minus of this cross. You can see this part. That is the, what is that, blue color. The rectangle the ones comes under cross multiplication. That is 2 into 1, 2 minus of this 2 into minus 2 plus 4. The next, you can see it. This, because we are expanding through by R1. So 1, 2, next here 2. So this particular row neglected, which you are taking the element, that corresponding row and column will be neglected. The balance 1 will be done for cross multiplication. That we have to adopt for determinant finding. So this is the cross multiplication. So here plus 2 and cross multiplication minus 4. This minus of this cross. So we done it. Only one thing we have to remember. The position, sign position, or we have to be very careful to avoid the careless mistakes. Positive, negative, positive. Very simple one. That is positive, negative, positive. Sign values also we have to remember. Throughout this determination of finding, I used it wherever the negative, the positions are there, the pentagon shape is used. So the value minus 3, minus 12, simplified, and that's the value we got it, minus 27. So we can see it now. So next we got the determinant, p value we got it minus 27. Next we have to move to cofactors we have to find. How to find the cofactors? Cofactors to find, this is the matrix, this is our model matrix. So not a given matrix. Given matrix means our question. This is our model matrix. With the help of eigenvectors, it is framed. So all the cofactors, 9 positions we have inside the matrix, 9 elements are there. The 9 elements, which sign it possesses also. Problem sign also is there, and the position signs also is there. Now first I am taking this, the rectangle, that red color, that one. This we have to do the completely row neglect, column neglect, balance one we will do the cross multiplication. Which position we are taking the element regarding corresponding row and columns are neglected. The balance 1, it is done cross multiplication. That we have to keep it in our mind. Now, we can see here, cofactor of this 1 is the cross multiplication is there. The determinant of this, the balance 1. So 1 minus 2 minus 2, 1. We will do the cross multiplication. 1 minus of this cross, it's nothing but 1 minus 4, we got it, minus 3. So the cofactor of first element is, that is, first row, first element is completed. Among the 9 cofactors are there. First one we completed. Now we will move to the second one, that is this one. So you can see here, yes. This we are going to, this position is negative position. That's what I told already. For the negative purpose, I used that to understanding pentagon shape, I used it. So this, we know it, corresponding row cancel it, column cancel it. The balance 1, that we have to do the cross multiplication. That cross multiplication, the determinant value is becoming the cofactor of this 2. That's why here this minus sign is the position sign. Then the balance 2 minus 2, 2, 1. It is written. Determinant, we know it. Cross value. This sign minus 2 minus of this minus 4. It's nothing but minus 6. So 2 we completed. The next, the first row, one more is the balance. That is, we can see it. That is this position. So it's very simple thing. Now we got it. That particular row and column we have to neglect it. The balance 1, the determinant is becoming the cofactor of this 2. So yes. Now it's very simple thing. Cofactor of this 2 is this cross multiplication. That is determinant of 2, 1, 2 minus 2. Minus 4 minus of this cross minus 2, we got it, minus 6. So the first row, the cofactors, if it is this position, minus 3. For this position, we got it minus 6. This position, we got it minus 6. First row we completed. So among the 9 elements, 3 elements cofactor we found. Left over 6 cofactors are there. Now we will see that also. Yes. Now we are going to concentrate the second row, first element. The position is minus sign. Next. We know it. So this we will cancel, Balance the remaining part only we will be taking cross multiplication. So this is the cofactor of 2 is, because why it is, this position sign is minus. So where it is there, this rectangle, the in blue color, it is determinant we are finding. So it is 2 into minus of 2, minus of this cross is plus 4, it is minus 6. Next position is this position. What is the sign? It's very simple. This is negative and this is, next one is positive. Alternative signs only, the position signs will be there. Now we know it. Here it is there. Particular column we have to remove it. This is also we are neglecting. The balance part will become that part determinant value we have to find. So the cofactor of, so you can see it, which one? Yes, this, the blue color, the rectangle, the one, those elements which are rectangled in blue color, these elements determinant value we are going to find. That is cofactor of this one is determinant 1, 2, 2, 1. Just we did the cross multiplication, the value we got it minus 3. So next, which now we have to get it? Yes, we completed 1, 2. Here the leftover second row, that is the third element. because it's very simple. Negative, positive, this position is negative. Negative purpose, the pentagon shape is used. This particular row, no, not required. Yes, column is balanced one. We will do the cross multiplication. We will take the same, yes, cofactor of this -2. That is, it is a negative position. So it is used the determinant 1 to 2 minus 2. So the values we got it minus of this -2. Here we got it -4. So the value is 6. So now it is, we are going to concentrate. We completed R1, R2, and the last one is R3. So here 2, this is the actually, this particular row is cancelled, particular column is cancelled. Now 2, 1, 1 minus 2. So the cofactor of 2 is the determinant of 2 to 1 minus 2. We will do the cross multiplication. That is 2 minus 2, that is -4. Minus of this is -2 equal to -6. This position, because this is positive, means this position is negative. And this particular column, no. This is also no. Balance we will take for cross multiplication. Sorry, it is the position, it is written. Here it should come, this is a rectangle part. It should go up. The animation, it should go up. So now 1, 2, 2 minus 2. It is written here correctly, but animation part, it should come here. So minus of -2 minus 4 equal to 6. Now this is the last position. So we know it. This one, it is, we are neglecting. This is the rectangle. We have to do the cross multiplication. So now cofactor of this one is this, what is that? Determinant. So this up 1, 1 minus of this, it's 1 minus 4 equal to -3. So all the 9 cofactors, we got it. So this is the cofactor matrix, which is with the help of cofactors, we framed this matrix. And we are doing the transpose of this cofactor matrix. That is, the first row is written first column. Second row is written, it is second column. Third row is written third column. That is, a row is interchanged by columns. That is the meaning of this transpose. Yes, it is done here. This is the transpose of cofactor matrix. The transpose of cofactor matrix, it's nothing but adjoint. Determinant P already we found, that is -27. This is 1 by determinant P. That is the reason -1 by 27, and this matrix is written as it is. This we copy it. Now this is inverse P. So this problem diagonalize. So it's really, it's taking, moving. But in exam, eigenvalue, eigenvector we can find. To find inverse, the students can use the calculator at just one step. Looking at the using the calculator, they can write this matrix. But the lecture, it is explained. In the exam, calculator using P inverse can be found. So just here -3 is common. So -3 is taken out. So it is becoming 3 by 27. It's nothing but 1 by 9. So -3 coming out, we got it. 1, 2, 2, So second row 2, 1, minus 2, plus 2, minus 2 and 1. So P inverse also we got it. Diagonalize, the formula is P inverse AP. So the P inverse we substituted. A is our given problem, given matrix. P is nothing but our model matrix. It is framed with the help of eigenvectors. Now we have to do the multiplication. First these two we will do it. Yes, it is written as it is. We know it. The first row taking the first matrix, first row we will take. We will finish the columns of second matrix. That is the multiplication, matrix multiplication doing the way. That is here 1 into 8. 2 into minus 6, 12. 2 into 2 over. First row taking, first column we completed. But first row taking, more 2 columns are there. So first row taking here 1 into minus 6, 2 into plus 14, 2 into minus 8. Now first row, second column is completed. Next first row, third column 1 into 2, 2 into minus 4, 2 into 3. First row taking, our job, our work related to column of second matrix is completed. Now we will move to first matrix, second row. First matrix, second row, work with all the columns of second matrix. We have to keep in our mind row first column, column second matrix. That we have to remember. So 2 into 8, 1 into minus 6, minus 2 into 2, 2 into minus 6, 1 into 7, minus 2 into minus 4, 2 into 2, 1 into minus 4, minus 2 into minus 6. Similarly, we can do this also. It is written as it is. This is only the simplifications. We solved these values. We got it, this one. And this is written as it is. This multiplication also done the similar way. First row, columns. We know it, all the elements are 0, 0, 0, it is there. This one we will see it. 6 into 1, yes. 3 into 2. Position third element, here also third element. Completed. So, second row, first column is completed. 6 into 2. 3 into 1. Minus 6 into minus 2. 6 into 2. 3 into minus 6. Minus 6 into 1. So, we completed that is the second row taking all the columns of the second matrix. Again, it is repeating the matrix, first row, second row, third row. First row taking the work related to columns of the second matrix. Calculator is allowed while for the examination purpose writing, but we must know how to do the multiplication doing manually. That is the reason in this video lecture it is completely explained. So 1 by 9 as it is. So solving this value we got it 0, 0, 0, 0, 27, 0, 0, 0, 135. 1 by 9 is taken inside, 27 by 9 0, and 135 by 9 15. So we can notice here the principal diagonal 0, 3, 15. They are nothing but our eigenvalues. So we diagonalize the square matrix, that is our given matrix, this is the diagonal form, we got it. So diagonal form, we know it. The elements which lies on the principal diagonal, the rest and all will be zeros. The elements will be 0, that is a diagonal form. So it is nothing but it's a spectral matrix. So we can see it. So far what we have done, it's a lengthy problem we did. Given matrix is there. This is our question. We found eigenvalues 0, 3, 15, we got it. And this model matrix we found, that is using these eigenvalues, corresponding eigenvectors we got it. With the help of those eigenvectors, that is lambda equal to 0, this is the eigenvector. When it is 3, this is the eigenvector. When it is 15, this is the eigenvector. The formula for diagonalization is P inverse AP. So P inverse, we got it. So that's a lengthy procedure we did actually. The inverse, we know it. First determinant P we found. All the cofactors we found. While doing the cofactors, this position signs we have to remember. And the cofactor matrix, we got it. Again the cofactor matrix, we did the transpose. It's nothing but adjoint. So P inverse, it's nothing but adjoint by determinant P doing, we got this one. Next, we substituted here, we got this diagonal form. What a beautiful concept here. You can see this is lambda equal to 0 eigenvector. But while doing the diagonalization, the lambda value, while solving it, has come. Now, this is the eigenvector for lambda equal to 3. So, while solving, we got it here 3. This is eigenvector lambda equal to 15. While solving, we got it 15. But if we are changing the order, suppose this is coming here, automatically, suppose this is the lambda equal to 15 eigenvector. If we are placing here first and we are solving, automatically the 15 will be here. That is the beautiful concept of mathematics learning. So we completed the problem diagonalization. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.